Okay, so people wonder why we study quadratics and why we do all the graphing. Why were we doing all that graphing? And that's going to become clearer probably as we start applications. But there's a lot of things going on here, and you will find great success in this unit. Word problems, which are scary to some people. If you take some time and make connections between all these different things that we're doing. Factoring, expanding, graphing, completing the square, vertex form, transformations, all these things all have to do with the same ideas. So let's take a look at this here. I have two things that are very similar. Is everybody watching? Y equals x squared minus 8x plus 12, and 0 equals x squared minus 8x plus 12. One of them looks like a graph. The other one looks like an equation to solve. Okay, so the graph I'm going to graph. I completed the square. I already did that. And so that's a horizontal shift to the right 4, a vertical shift down 4. And my growth pattern is unchanged. So over 1 up 1, over 2 up 4, and so on. Okay, and I could keep going, but there is a rough look at the parabola of that y equals x squared minus 8x plus 12. What if I solved this? 0 equals x minus 2x minus 6. Therefore, x equals 2 and x equals 6. And what do you notice? Those are the x-intercepts. 2 and 6. Why? Because what I did was I replaced y with 0, and essentially x-intercepts occur when y equals 0. So this was the algebraic, but I did it by factoring, which we didn't know how to do 2 units ago, but I did it by factoring, the algebraic way of finding the x-intercepts. Sub 0 in for y, solve for x. Same thing, solving by factoring when it's equal to 0 like this is finding the x-intercepts of that equation, of the related quadratic function that you could graph as a parabola. Does that make sense? So I've got it in standard form. I can factor to find the x-intercepts or to solve it. I could complete the square to find where the max or min value is and to graph it if I wanted to. Okay, these are the skills that we do. How does that help us? Again, let's take a look at this. There's 2 different ways of looking at this. X squared plus 4. No horizontal shift. Shift up 4. So I go up 4, and I go over 1, and over 2 up 4. I think that's right. That's fine. And I solve it like that. What's the other one? The other one is a shift down 4. Still opens up. No horizontal shift. One of these has x-intercepts, the other doesn't. What about the associated 0 equals x squared minus 4? Move the 4 over. Take the square root of both sides. Plus or minus 2, the x-intercepts. What about this one? Negative 4 equals x squared. Square root of both sides. Remember we said that before, you can't do it. And there are no x-intercepts. What would a parabola look like that was a perfect square trinomial and had one solution? What would the associated graph look like? These are the connections that will help down the road. Okay, this is big stuff here. Thinking about the graph, setting y equal to 0, thinking about the equation, going both directions. Okay? Cool. Something to think about. And as we get into applications, it'll kind of come up over and over and over again that these aren't different things. It's not like we do one, then we stop, then we do the other. It's all the same stuff. It's all skills towards the same stuff.